Lie still inside a giant magnet and a machine draws a map of the inside of your body. No knife, no X-rays, just magnets and radio. In the next few minutes, we slice open an MRI scanner and watch how it turns the plain water in your cells into a clear, glowing picture. It feels like magic when you first see it, but it is really just physics, done very, very carefully and listened to with enormous patience. Start with what you are made of. Most of your body is water, and every water molecule carries hydrogen. At the center of each hydrogen atom sits a single proton, spinning like a tiny top. That spin makes each proton a faint magnet, with a north end and a south end. Normally, these little magnets point every which way and cancel each other out. Trillions of them, aimed in random directions, add up to nothing a scanner could ever notice. Now slide into the scanner. Its core is a magnet thousands of times stronger than the one on your fridge, cooled close to absolute zero, so it never tires. In that fierce field, the spinning protons can no longer ignore it. Most still cancel in pairs, but a tiny surplus swings into line with the field, like compass needles snapping toward north. That faint lined-up majority is the whole signal. Everything that follows is a quiet conversation with it. Lined up, the protons are silent, so the machine wakes them. A coil sends a precise pulse of radio waves tuned to the exact rhythm at which these protons wobble. When the frequency matches, they absorb the energy and tip sideways, all leaning together, now spinning in step. It is like pushing a child's swing at just the right moment. One clean nudge, and the still silent protons begin to sing back in a single shared voice. Then the pulse switches off. Set free, the protons begin to fall back into line with the big magnet, releasing the energy they borrowed. As they relax, they broadcast a faint radio signal of their own, a fading echo from deep inside your tissues. Receiver coils, wrapped close around you, listen for that whisper. It is unimaginably weak, but it carries the secret the scanner is after, where the protons are and how each one behaves. One problem remains. A plain echo tells you protons are singing, but not from where. So the scanner cheats with geometry. Extra coils, called gradients, tilt the magnetic field so it is slightly stronger at one end of you than the other. Because a proton's pitch depends on the exact field it feels, each slice of your body now sings at its own frequency. Position becomes pitch. The loud knocking sound you hear is those gradients switching on and off. Here is why the picture has detail. Not all protons relax at the same speed. Those in fat snap back quickly. Those in free water linger. Those bound in tough, dry tissue behave differently again. The machine can wait a chosen moment before it listens, so fast tissues and slow tissues hand over their signals at different strengths. Fat, muscle, blood, and a tumor each answer with their own brightness. That difference in timing is what paints the contrast. Sometimes the body needs a little help to stand out. For tricky questions, like a leaky vessel or a hidden tumor, a harmless dye called a contrast agent is injected into a vein. It is faintly magnetic, so it speeds up how nearby protons relax. Where blood flows freely, the dye gathers, and those regions flare brighter on the final image. The scanner itself did not change. The water near the dye simply learned to shout instead of whisper. Now the hard part, done in silence by a computer. What comes back is not a picture, but a tangle of overlapping frequencies, all arriving at once. A piece of mathematics named the Fourier transform untangles them, sorting the blended signal back into who sang at which pitch, and how loudly. Each pitch maps to a place, each loudness maps to a brightness. From a single chord of radio noise, the machine rebuilds a clean grid of dots. Repeat this, slice by slice. The scanner steps its gradients and sweeps through your body in thin layers, like cutting a loaf of bread. Each layer becomes one flat image. Stack those images in order, and you have a full three-dimensional map, which a doctor can scroll through from almost any angle. Nothing was ever cut. The blade was only a magnetic field, and the slices were drawn out of the echoes alone, one careful layer at a time. And notice what never happened. No X-rays passed through you. No radiation was used at all. The whole image was built from magnetism and faint radio, the same family of waves that carry your favorite station. That gentleness is why an MRI can be safely repeated, and why it is trusted to study soft things, brains, joints, and hearts that older machines could barely see. The price is the magnet's enormous power and the patience the picture demands. So trace the whole path. Your body is mostly water, full of spinning protons. The giant magnet lines a few of them up. A radio pulse tips them over, and as they relax, they sing back a faint echo. Gradient coils stamp each location with its own pitch, while the timing of the listening separates one tissue from another. A Fourier transform turns that chord into a grid, and slice by careful slice, the grid becomes a body. No blade, no radiation, just water, magnets, and patience, listening to the quiet radio song of your own atoms. The next time you see one of these scans, remember the proton that tipped, sang, and fell back into line millions of times over to draw you from the inside out. That is the MRI. Thanks for slicing it open with us today. We will see you in the next one.